Hey everybody, today we're going to talk about circle graphs. So your I can statement is I can use circle graphs to answer questions in problem situations. So let's take a look at a few characteristics of circle graphs. A circle graph is a graph that displays data as a part of a whole. The entire circle represents 100% of the graph. So this equals 100%. The data represented in a circle graph can be used to solve problems including percent, part-to-part, and part-to-whole comparisons. All right, so let's take a look at the first example. The circle graph shows the percent of vegetables planted in a vegetable garden. There are 200 vegetable plants in all, so this is a total. All right, because it says in all. All right, A, how many vegetables planted were tomatoes? Okay, so let's take a look at what we got here. We got 32% out of 100% total. So when we're doing this, we're going to do the same thing that we did on the bar graphs and the line plots and all that kind of stuff. I mean, dot plots. So we're going to write tomatoes to total. And we're going to write the ratio of percents, tomatoes to total. So 32 to 100. Then we're going to set it equal, just like a proportion or a one chart. There are 200 total vegetable plants. So we're going to set that equal to our total of 200. 100 to 200 is times 2. So 32 times 2 is, oh, if I don't know that, I got to multiply it out, right? Ooh, 64. So therefore, there are 64 tomatoes planted. All right, let's keep going. B, how many vegetables planted were peppers and cucumbers? So once peppers and cucumbers. So, peppers and cucumbers. So peppers and cucumbers, that's 11 and 9. So we want peppers plus cucumbers out of the total. So 11 plus 9 equals 20. So 20 out of a total of 100. And we need to figure out how many vegetables were planted. These are percents. We need total 200. Okay, total 200 times 2 again, 40. So 40 peppers and cucumbers were planted. All right, C, what fraction of the total number of plants are corn plants? Okay, so we want to make a fraction. The great thing about percents here is we know that the total is 100, and we know that corn is 36. We can actually write that in fraction form and simplify it, and it would be the same as if I was to find how many total there were of corn plants out of the 200 vegetables. All right, so let's go ahead and show that. So corn to total. Corn is 36. Total is 100. Simplify it. Looking at it. Let's start with 2 because, you know, if they're even, they're divisible by 2, right? Half of 100 is 50. Okay, 36 divided by 2. 2 times 8 is 16. 18, 50 is, oh wait, it's even again, divide by 2. We could have really just divided by 4, but I wanted to make sure that you guys could do this on your own without my help. So 18 divided by 2 is 9, because we figured, remember, 2, oh, I'm sorry, I didn't do that right, never mind. Okay, 2 times 9 is 18, and 50 divided by 2, half of 50 is 25, and if you don't know that, set it up, divide it out. Okay, 9/25. And there's your answer there. Let's take a look at one more example. This is when we add in your personal financial literacy part of the unit. We use circle graphs for that to create a budget. So the circle graph shows the results of a budget Riley created for his expenses during his junior year of college. Riley has a total budget of $5,000. Write a ratio that compares the part of his budget allocated for clothing to the part of his budget allocated for food. Express the ratio as a fraction in simplest form. Okay, so we want to compare the ratio of clothing to food here. So let's come over here and look at clothing. Clothing was 15% to food, which is 20%. Now it says express this ratio in simplest form. So I need to simplify it. So instead of leaving it in that ratio form, let's write it in fraction form. And let's simplify it from there. Ends in 5 or 0, so it's divisible by, you guessed it, 5. 15 divided by 5 is 3. 20 divided by 5 is 4. So the ratio is for every $3 used for clothing, $4 will be used for food. All right. So that was one of those part-to-part ratios that we were talking about in the instructions on the first page. Riley has a total budget of $5,000. Okay, how much money is he allocating for housing expenses? So let's remember what we know. The circle graph is full of percents. And the total number of percents, if I was to add 60 and 20, that's 80. 80 plus 15 is 95, plus 5 is 100%. Okay, so let's go ahead and write our ratio of what we're looking for. We're looking for housing. All right, so housing to total. Do it again. Housing is 60, total is 100. Where'd I get that from? Right here. Okay, and I got $5,000. Well, that's the total budget, so this is going to go in the total. Okay, now I need to figure out how many times 100 goes into 5,000. I'm going to kind of cover up these 2 zeros here, that's 1, and cover up these 2 zeros, that's 50. 1 times 50 is 50. So therefore, 100 times 50 is 5,000. So I need to do 60 times 50. Okay, place value. 5 times 0 is 0. 5 times 6 is 30. $3,000 for housing. It's a lot of money for housing, but it happens. Okay, so Riley has a total budget of $5,000. How much more money is he using on housing than food? We already know how much he's using on housing, so we know what housing is. Housing is $3,000. We need to figure out what food is. So we're going to do the same thing we did here. Food to total. Okay. Food was 20 over 100. 5,000. Got to find that missing piece. Okay, do the same thing as before. Cover up those 2 zeros, cover up those 2 zeros. 1 times 50 is 50, so 100 times 50 is 5,000 times 50. Okay, 20 times 50 is my answer. Multiply it out, 0, 0. 0 for the place value. 5 times 0 is 0. 5 times 2 is 10. Add it up. $1,000. So we're using $1,000 for food. So it says Riley has a total budget of $5,000. How much more money is he using on housing than food? He wants you to subtract. So 3,000 minus 1,000 is 2,000 more dollars on housing than food. All right, everybody. Hopefully you learned something from this and you can use this to help you answer your questions in your Google form. You guys have a great day. Bye.